recording. Is it recording or did it break?
Hello, everyone.
Okay, one second.
Thank
Let me
you
just
for
try
being
this
here.
again.
It was recording. Hey everyone. Welcome to another session. And today we're just continuing with what we did yesterday. So yesterday I introduced you to smart contract. So I'm gonna start by just flying through with what we did so far. Can you see my screen? Okay, the objective was to write, build, and test and deploy your first smart contract, and also to understand the basic skeleton of a smart contract. And I also mentioned that whenever you compile your project, you turn it into a Wasm file, and that's what you use to upload to the blockchain. In this case, you're working with the testnet. And the tools that we are using is the Soroban CLI, which I showed you how to install. So what is Rust? This one you already know. And we also spoke to you about how to create, how to set up your smart contract. And yeah, we're going to start with Hello World. So as I mentioned, the first line of your smart contract is this line here. So no STD. So it's very crucial to have it. And it tells the compiler that you're not going to use Rust standard library, because Rust standard library is large. You don't want to include it here. We're dealing with smart contracts, so we want to be as light as possible. And when we compile, we want our file to be less than 64 kilobytes. So that's the limit that we can upload on the Stellar blockchain. And so this is the structure. And another important part is a contract, a macro. So this contract macro marks the struct as a smart contract. And notice that it's empty. Let me go back. So and then we also, under that, we have implementation. So this is where you implement all your functions. So yeah, let's keep moving. And now here, I'll skip this part here. We also have to import Soroban SDK. And we also have to define what exactly are we going to be using in our smart contract. In this case, we are using string and vector. Environment will always be there because we're dealing with the smart contract. We're dealing with a blockchain environment. So this one is only going to be here. Contract as well, contract implementation. Will always be here when you're creating a smart contract. And here it talks more about what I just mentioned. And here we are importing Soroban SDK and all that we need to be using. And using our macro. And yeah, now we add the functions. So here we created the function called hello, and it takes one thing on the perimeter, and it's 2. We're taking 2, which is a string, and it's going to return a vector of string. So in the parameter, we have env, which gives us access to the blockchain environment. And then we have 2, which is a Soroban compatible string. This string is not from Rust. This string is from Soroban SDK. It's the optimized version of a string created specifically for Stellar blockchain. And for example, if we put dev, a string dev called dev inside our parameter, this is what we expect as a result, a vector of hello and dev. This is what our hello world project did. And another thing when you're creating a smart contract, you always have to test it. It's a very important step. And this ensures correctness, security, before you deploy to a blockchain. So you test it first on the test net, and then you deploy to the test net, you play around on the test net, and then you deploy to the mainnet. So this is basic skeleton of test. Notice that it starts with this. This tells compiler that here we are testing. It's not going to be running when we build our Wasm. When we compile, it's not going to build using this. It's going to ignore it, but it's only going to be used specifically for testing purposes. So again, we use whatever comes from, we're going to be taking whatever we have from our super is our smart contract, and we're also using the environment and string because we're going to be using it here as well. So we have to define that here. So this line here, env equal env default, it's a method that creates a local test instance that mocks the blockchain environment. Because here we're not in the real blockchain environment yet, but we want to create sort of a fake version of blockchain, but behave the same way as a blockchain. So this allows testing without live network connection. So you can test on your local machine. And here, like before we write the test, we have to put this directive so that everything that is under here is going to be a test. So if you have many tests, then you're going to have a lot of them in the same file, like test, and then you write your test, and then another test with different tests. So you can have multiple tests in the same test file. And here now we deploy this line here, env register, deploys a contract to the test environment and returns a unique contract ID that we're going to use to interact with the blockchain. And now here we're using our function. We're calling the hello function. So we created a client that's going to interact. So a client is kind of like the address that's going to interact with the blockchain. And now we've called the client, and now the client calls the hello function. And remember, this is just going to return a vector of 2 strings. And whatever we put here, now we expect, since we put dev inside our parameter, we expect the output to be hello dev. If you put David here, you expect it to be hello David. So whatever you put here, that's what you expect. So here you're just testing it to make sure that they inputted what you input. You definitely get the expected output. So while you're testing, you also have to make sure that you know what is the expected output. Because if you don't know the expected output, you're not going to know what you're testing for. So the expected output is hello dev, and I have words here. So I want word to be the same as hello dev. So if it's the case, then I pass. So this is basically repeats what I just mentioned, the ENV default creates a simulated blockchain environment that runs locally, not the real network. The ENV registers the contract inside the test environment, effectively simulating a deployment. Registration returns a unique contract ID used to interact with this specific instance during the test. So this setup ensures tests are isolated, deterministic, and fast since no network calls are made. Okay, so this is just for repetition for you to just understand what's happening here. And then the Stellar test, which we did yesterday, and contract build. Let me show you how that happens. Let me show you that to you in action. Let me show you, where is it? Okay, so here we had our Hello World project, and one step that I didn't mention was in this project, I can create another project or another smart contract under the same folder, because here we created a Hello World folder. Remember what we did yesterday? And I can create another project. So we do that by Stellar init, and then a dot, and then name. So we put name so that we don't overwrite on our folder, and then we can call, let's see, what name can I give? Example. Now I forgot something here. Stellar contract init. Stellar init contract. So what did I call it? Example. Okay. So you can see on the left. Let me just increase my. Let me increase it. You can see here we created a new contract under the same folder, Soroban Hello. So now here we have 3 contracts under the same folder. We don't have to recreate another one. And I already created another project called Increment from my other video that I uploaded it on YouTube, where I go through all the steps. So we're gonna deal with increment. So there's 2 files here. There's a smart contract, and then there's a test file. There's test file, and but before we get there, let's deploy Hello World. Let's just see how it is to deploy a smart contract. So we're going to deploy a smart contract just for you to see how that goes. Let me clear this. So to deploy, the first thing that you have to do is Stellar contract build. So this is going to build a Wasm file. And once you build that, it's going to create a Wasm file. And that Wasm file is what you use to upload to the blockchain and also interact with it. Okay. So why are we busy here? Because we want to make the most of our time. We're going to go back to increment. Oh, there we go. There's some important things here that you'll see. We have the Wasm hash. And we haven't yet deployed. And if you go to, now let's look for our build, our Wasm.
Inside target.
Oh, yes. Oh, thank you. Release. Oh, there is Wasm none. Release. And these are the Wasm. We have the Hello World Wasm. We also have the increment Wasm because we build all our project, our smart contracts that is in the same folder. So we have the increment Wasm, we have the example Wasm as well. So that's what we're going to be using to export. So now let us deploy it on the blockchain. But before we do that, we need to have an address to be able to do that. So we're going to create a key pair. Stellar keys. Let's call it net generate. Net. And we have to also specify which network we are. And the network is the test net. If I'm hiding, let me put myself somewhere. Test net. Test net. And we also have to fund it because we're going to be on the test net. If your address is not funded, it's not going to be active. So we also fund. So using this, we'll fund our account with 10,000 XLM. So Stellar keys generate the net will be the alias of our address. So it's kind of like a representative of our address. And we have a network on a test net. So we add the fund. It's going to create a Stellar identity. And yes, account is funded. So now let's see what is our address. So to see our address, we use this command, Stellar keys address net. So this is your address. So we're now going to deploy. Just get a notepad and show you So this one, I'm just gonna copy from the docs. Where is the docs? Put the testnet. Just to save time. Come on. Okay. So I'm gonna change the name to Linet. And testnet alias for the world. So what I did was just copy from the docs and they deploy. So we are deploying. This is our target, our Wasm, hello Wasm. And the source account that is deploying is Linet. So Linet will be the source account of this smart contract. And the network is a testnet, and we're also going to give it an alias. We're going to give an alias to this Wasm and this contract. I'll call it, when I call our contract hello world. So press enter, and now we deploy to the testnet. And this is our smart contract address. We can actually see it on Stellar Explorer. Let me quickly go there. So I just copied it. I'm going to Stellar Expert. So we are in Stellar Explorer. Because we're in the testnet, make sure we're in the testnet. And we paste our contract. And yeah, so our contract is live. It was created by this account. So this is Linet account that we just created. So this was the source account. Now let's go back to my presentation. So we use Stellar contract test and then Stellar contract build to build it, and then we deploy to the testnet using the Wasm. We upload the Wasm file to the test to the network. And counter contact is very similar to the hello world contract. The only thing is here we are adding something to a storage. We are using a storage. If you watch my previous video, I mentioned the 3 different types of storage: the instant storage, there is a temporary storage, and there's a persistent storage. So we're going to see it in action. So what does state matter? Most real-world contracts need to remember data between transactions, like for example, balance, votes. So you need to find, there needs to be a way to remember that. So without state, contracts cannot track history or maintain application logic over time. State is stored on-chain and accessed through Soroban env object. So essential for features like escrow agreements, application statistics, and user count. So we have an example. Our example is a counter. And now let's look at use cases and what type of storage we can use. Token balances, there you're going to use persistent storage because you want to be able to see full history of your balance. And voting records, persistent, but In some case, maybe not persistent. You might also use instance. Oh, I mean temporary storage, depending on the type of voting it is. Maybe it's just a one-stop thing that you don't even want to remember about. And escrow deal is time bound. So counters use instance app statistic instance storage. And instance storage works similar to persistent storage, but it's more use case is for data like metadata and so on and so forth, like very small pieces of data. Stateful contract implementation. This is the example that is on GitHub. So here again, basic skeleton. We start with this, no STD, and then we have use Soroban SDK. We importing what we're going to be using. In this case, using the symbol and symbol short. We also added log, so this will help us to debug. And contract, which we always have to have contract. We also have to have contract implementation environment as well. And now here we create a constant called counter using a symbol and uses the symbol short for counter. So this creates, the symbol short creates a lightweight identifier, and this reduces the guess cost compared to standard string. So we could have used string, but we just want to be as light as possible. And we call it counter. So the counter is going to be used as a key that will point to a specific number, as you're going to see. And here we have contract. Under contract, we have the name of our contract, which is Struct. The name is increment contract. And under here now we have the implementation, and we also have our function. So what our function does is simply whenever you call our function, whenever you call the function, it should return a number, but the number must be incremented from the previous number. So if the number was 0, when you call it, the number becomes 1. When you call it again, the number becomes 2. So whenever you call it, there's an incrementation. So we have a public function called increment, and since we're not taking anything from our parameter, but we are accessing data from the environment, so we're only going to put env in our parameter, and we're returning an unsigned integer. And here now we're creating a mutated variable called count. And remember, when we did Rust, we have to be specific whether which is your variable. If you want our variable to be able to change, then it has to be mutable. We have to call it mute. And so now here is very important, and it's something that you're going to use a lot of time. And we go to the environment, env, we go to the storage, and we go to the instance storage in this case, and then we want to get something out of it. In this case, we want to get what counter is pointing to. Or if it's not pointing to anything, then the default will be 0. Unwrap all, the default will be 0. So at the first call, this is what's going to happen. At the first call of the function, count at this place, at this line, count is going to be equal to 0. And when you log this and you want to see for debugging purposes, you'll see that the count here is equal to 0. And then as we go down, the count now has been incremented by 1. And so far, we haven't returned anything. And since now we have 1, now we want to write it on the storage. And here we set. So environment storage instance. And remember, bear in mind that we're in the instance storage. So we're gonna write instance, and then we set whatever the counter is pointing to. We're going to set it, whatever this key is pointing to a value. At this point, it's pointing to 0. We're going to change that 0 to this count. So count here is 1. So it's going to be 1. And now we have 1 stored in the storage. The next step is you want to set a time for the data to survive in the blockchain. And this is when we use the TTL. And this simply means the threshold is 50 ledgers, and this is 100 ledger. So whenever, let's say we call the function and it reaches 50 ledgers, and then it goes down to 49 ledgers left before it expires. Because remember, whatever we put on the Stellar blockchain, like the data that we put, does not stay forever. We have to define how long it should stay. So whenever it's below 50, let's say after this 48 ledgers, this data will disappear. Whenever we call this function, when it sees that it's below the threshold, then it will kind of like reset it and extend it to 100 ledger. So it's going to stay alive for 100 ledger. So this will prevent expiration. But if we leave it, we don't call the function for a long time, then eventually it's going to disappear. It's going to expire. And the different storage, we have the instance storage, data type specific to the constraint instance, ideal for configuration counters and admin settings. We have persistent storage, which is long-term storage shared across the ledger, best for user balances and high-value records. We have the temporary storage, which is short-lived data that it expires quickly, suitable for Oracle price feeds and transient data. Just imagine you might not need to store the current price of dollar, because as you're getting it, let's say you want to get the price of dollar, like how much a dollar costs versus rands, you might not need to store it in the long term because that price is going to change anyway. So you use temporary storage for that. So this is how the basic way you do that. It's environment, storage, instance, or temporary, or persistence here. Like I mentioned, symbol is just a lightweight identifier used as a storage key, optimized for the blockchain efficiency. Use symbol short for strings up to 9 characters, which are stored efficiently as 64-bit integers. Defining keys as constants prevent typos and ensures consistency across contract methods. And symbol consume less gas than full strings, making them ideal for frequent lookups. And that's how it works. So we have counter here. So this counter is pointing to a value. It's not holding the value itself. It's just mapping to a stored value. So it's a logic flow of increment, read state, So we get, using get log value. Now we log it for debugging purposes. We modify, we increment it, we write, then we write it, count the new value, and then we extend TTL. Whenever we call the function, we extend its life. So the read, modify, write pattern ensure data consistency. The contract retrieves the current state, processes updates in memory, and then commit the change back to the ledger. So read, modify, write pattern. So that's what we did. We read, we modify, and then we write. So that's what we did. And this is something you're going to be using a lot when you building your smart contract. Of course, you're going to add other logic, but at the end of the day, you're going to have to write, and you're going to have to modify. You're also going to have to read. Log is just for debugging purpose. Yeah, storage is explained. I already explained it, and also explain why it exists. And so what this contract demonstrates, it demonstrates instance storage by using env storage instance to keep contract-specific data persistent on-chain. And the symbol key, you leverage lightweight symbol identifiers as efficient storage keys instead of strings. We just demonstrated TTL management, understanding time to live, and using extend TTL to prevent storage expiration, and state logic, implementing the standard read, modify, write pattern for deterministic updates. So you also learned contract structure. Like every contract has these macros, contract implementation macros to define the logic and expose public API method. And you also learn about why we use this and how env bridges your code to the blockchain state, and how we simulate the ledger with env default and validating logic with assert EQ before deployment, and also data storage. So this is something that you're going to have to do on your own. So this is pretty much very simple. Just make few change in the parameter, but then you can also extend it further. Maybe instead of returning a vector, what about just returning string? What happens when you return a string? Or returning a number, like how you go about it. So play around with that. And yeah, you can also go to the official tutorial from the official website, where you see how the whole flow. So this is just a better visual. It's the same thing, but just a better visual to see how things work, how to create a simple smart contract. So next step, and I'm going to create a video tomorrow. So just wait for the weekend. I'm gonna create this video for the guest book and task manager. So this is just going to be the next step, the next iteration from what you learn. Adding more complexity, creating a guest book, and then we're gonna move on to creating a task manager, and then escrow smart contract. So look out for 2 videos in the weekend. And next week, I'm going to make a video for the escrow, and I'm also going to talk about it in the class. And then token integration. So how much time do you have? Okay, for the last 10 minutes, we're just going to also play around with the counter smart contract to see how we can interact with it. But so far, does anybody have a question? Yes?
Is there like a local testnet?
A local
Or
testnet.
something similar to Foundry or Hard Hat?
Yes. So
Okay.
there is a testnet. So testnet is testnet. So Ben was actually playing around in testnet earlier when he, I don't know if you saw that. If you watch the recording, you will. But sorry, Ben, do you want to?
Okay, cool.
So let's see. Okay, let me put out this before time runs out. Quickly. Okay, going to quickly deploy this. Let me clear. You do not need to use a smart contract again, so let me clear. So now we're going to deploy our smart contract. So what we do is, let me just pull Notepad so I can make some changes. Net. And we have the increment Wasm, yes. So we're first going to upload. Going to upload. So, and the source account will be the account that we created. Okay, and we're then going to deploy. I just have to get this Wasm hash. Source is Linux. Good. So all this, you can find it on the, oh my goodness. I hate when this happens. So now we have our contract. This is our contract. Now we're going to interact with it. And to do that, we're going to invoke the smart contract. But we're going to be using gonna copy our smart contract and make sure we have the correct. We can use any. There's no privacy here, so we can use any wallet because we did not set authorization. It's open, it's public. So now here we're using Stellar contract invoke, and this is the ID of our contract, and the source currently net, and you see we have incremented it by 1 because we call the function. Because here we're just calling the function increment this side here. We're calling the function increment, and it does that. We do it again. Signing transaction. Come on. Now it's 2. So this is communication between me and a testnet in real time. So yeah, that's it for tonight. Any question before we leave? Okay, thank you guys. This is the end. Hello.
Good evening. I just wanted to apologize for showing up very late today. I had a meeting before this, but I wanted to ask about the slides that you had on display today. Will they be available after?
Yes, I'm going to add it to. I'm going to add the link on the GitHub.
All right.
And I'm also going to do that on Discord. Thank you. Thanks for coming tonight.
And then I'll add it to the.
You add it
Sorry,
too?
and then I'll add it to the YouTube as well. Sorry, guys. To the YouTube video as well, if you want to get a recap from what you missed earlier today.
Thank you.
Thank you, Ben. Appreciate you guys for joining as well. Thank you so much for joining. Enjoy your night.
Thank you.
It says